Once upon a time, Kepler looked at the sky, at stars, at things, and thought, "Hey, I should write 3 laws! First law, planets revolve around the sun, and I think we should all be okay with this. But they don't actually go around in circles, they have elliptical orbits, so just like circles but a bit squashed. Also, the sun is not at the center, it sits here, on the so-called focal point. The closest point to the sun on each orbit is called perihelion, while this point is the furthest from the sun and it's called aphelion. Second law. The orbit radius, this guy here, sweeps the same area in the same amount of time. So, if this thing starts, okay, you can see that after a second the planet radius created a certain area, and after another second it created another area. Well, these two areas have the same value because they were created in the same amount of time. This means that planets go faster the closer they are to the sun and go slower the further they are from it. Third law. Okay, take a T. T here is the time a planet needs to take a ride around the sun. He's a good boy, so let's give him a power of 2. Now add an A. A is the orbit semi-major axis, so the orbit biggest radius. This guy gets power of 3. T squared over A cubed has the same value for each planet in the solar system, even Pluto, even if its premium account expired and it's no longer a planet. This value is 4 pi squared over G times the sun mass. G is a tiny number, 6.67 times 10 to the power of minus 11. And you're gonna see it again pretty soon, so watch out. However, people asked Kepler, "Kepler, my dude, but why do planets move around the sun?" But Kepler skipped that lesson and he failed his physics class. But then Uncle Isaac came and said, "Yo, I'll tell you why planets do their stuff. You see, there's gravity. This is the formula for the gravitational force. Take the product of two masses and divide it by the square of the distance between them. Don't forget that square, for force sake. If you do, Albert's gonna come and break your ankles. And be careful, you morons. D is the distance between the center of the two masses. So like this, and not like this, god damn it. Then put the big G in front of everything and there you have it, gravitational force. If you're wondering, yes, this G is the same G of my pal Kepler, 6.67 times 10 to the power of minus 11. It's called the gravitational constant. This is gravity. Gravity is what binds Earth to the Sun, and the Sun to Earth, and you to Earth, and Earth to you. But Uncle Isaac, I thought that gravity was just m times g. You see, m times g is just a formula for you morons living on the ground. It only works while you're close to the Earth's surface, but it becomes trash when dealing with planets, stars, aliens, and spaceships. Forget about it. This is the real deal now. And please do not put a vector over here, like no. This is not a vector equation, it's just telling you the force magnitude, its value. What? You want to know how to draw it as a vector? Just remember that this force allows bodies to attract each other. Take two objects, each one of them is gonna have a gravitational force acting on it, pointing towards the other one, and these two forces have the same value. Now, any other intelligent question? So, does it mean that I can, pull my cat with my gravity force, like abracadabra, accio and stuff? No. Take a look at the numbers. Even if you have just eaten 3 servings of your grandma's lasagna and your mass is 80 kilograms and your cat has just eaten his own grandma's lasagna and weighs 10 kilograms, the gravity force you generate on your cat from a distance of 1 meter is just 0.00005 newtons. A sneeze would probably be more effective. Matteo, but I still don't get why the sun and the earth and planets attract each other. I mean, they don't even touch each other. Is gravity like some kind of magic working at distance? Not at all, and even Uncle Isaac knew that there must be something more behind this mystery. So one day scientists got together and said, "Ladies and gents, gravity force is crap. Let's figure out something new. We're gonna call it field." And someone asked, "But why field and not banana?" And they got defenestrated. You see, gravitational force is a bit of a gimmick. Saying that bodies attract each other is not an accurate description of what's actually going on. The key idea is that any mass, be the sun, earth, anything, creates a deformation of space around itself. Just like when you're sitting on the couch and you create a pit everything's gonna fall into. Your smartphone, your TV remote, and your grandpa. No force is actually coming from you, just like no force is actually coming from the sun. It's just Earth moving inside the sun hole. But if you don't see the hole, you think, wow, the sun is attracting Earth, but it really isn't. Earth has its own hole too, but it's so tiny that its effect on the sun is almost invisible. This deformation produced by masses is called gravitational field. If you want a first-person experience of how a field works, cover yourself in blue cheese and don't take a shower for a couple of weeks. Then go for a walk downtown. I'm telling you, you're gonna create a perfect reverse gravity-like effect, because you will repel animals, things and people without even touching them. We could say you're deforming space around yourself, but we'd better say that you're deforming air. At the end of the day, what matters is that there's no force repelling young and adults. It's just their own deep desire to get away from you as fast as possible. This is how a field works. And if you're thinking, oh my god, I know some weird-ass equation is coming.
What's that? And this and...
No, take it easy. Here's a simple one. The gravitational force felt by a mass m is equal to that mass times the gravitational field g. But be careful, g here is not the gravitational field produced by the mass m. It's the field that mass is sitting in. Like the gravitational force Earth is feeling due to the sun is Earth mass times the sun gravitational field. If you want to calculate g, here's the trick. G at a certain distance d from the mass m producing it is capital G times m divided by d squared. It's just like Uncle Isaac's gravitational law, but with only one m. Wait a second, Matteo. Go back a second, please. Matteo. What the hell is that? What? Guys, the gravitational field is a vector. Deal with it. We said that a field is a deformation of space. You must imagine that at each point in space there's a sign with an arrow pointing towards the center of the hole. So, if Earth passes by, it can simply ask, "Excuse me, which way to the sun?" And you can say, well, just follow the signs. Long story short, the gravitational field is telling you the direction and the sense of the gravitational force at each point in space. That's why it's written as a vector. And now it's finally time for the sexy example! You know Borderlands, don't you? That game where the bad guy is called Handsome Jack, even if he's ugly as f***. Okay, so Jack owns a huge space station floating in space between the planet Pandora and its moon Elpis. What we're gonna do now is calculating at what distance from the planet the space station must remain in order to stay still, pretending we know Elpis and Pandora's masses and the distance between them. Let's go! The space station stays still if Pandora's gravity balances Elpis' gravity. The two forces are balancing each other, so the space station can't move. But I tell you, we can go hardcore and say the space station stays still if Pandora's gravitational field balances LP's gravitational field. If these two gravitational fields cancel out, the space station actually feels no force and it's not gonna move. But before proceeding, you should really do two things. First, subscribe, and second, draw a good frame of reference. Like this one. Every distance from now on it's gonna be measured from the center of Pandora. X here is what we're trying to calculate and D is the distance between Pandora and Elpis. Thus, D minus X is the distance between Jack's space station and Elpis. Now you can finally write the formula for these two gravitational fields. Pandora's G is big G times Pandora's mass divided by x squared. Elpis G is big G times Elpis mass divided by d minus x squared. So look at this. G and G cancel out and GG. If you solve this second grade equation, you get this solution for x. And we are done. Say goodbye to Jack. Remember, you can support this project with a tip. It really helps me keeping these videos going and constantly offering you new content. A huge thank you to all my supporters. You guys are the ones who make this possible. Don't forget to subscribe and leave a like. See you next time. Ciao!